Okay, are you all able to see the screen?
Yes, sir.
Okay. Okay, so yesterday we have started types of forces. How many fundamental forces do we have? How many fundamental forces do we have? Bhavya, Yashasvi?
Sir, 4, sir.
How many?
4, sir.
4. Huh? Okay. What are they? What are they? Yashasvi?
Yes, sir.
What are they?
So you're able to hear my voice?
Ah, I am able to hear your voice. Bhavya, Yashasvi's voice was distorted. It
Yes,
is
sir.
so much noise is there. Ah, please tell how many forces and what are they?
So we have four forces. They are gravitational force, the normal force, then tensional force, and spring force, I guess.
Ah, these are the forces which we are going to study. Fundamentally, how many forces do we have?
So fundamentally, gravitational force, electromagnetic force,
Correct. Strong
and
nuclear force.
force and weak nuclear force.
Correct. Very good. And out of these four forces, nuclear forces we'll study in second year, and the first two forces we are going to study in the first year. So out of those forces, that is first two forces, gravitational force and electromagnetic force. Out of these two, gravitational force is a separate force, fundamental force. And now this electromagnetic force is of different types. Number one, normal reaction force, tensional force, spring force, frictional force. All these forces come under the category of electromagnetic force. Okay. So yesterday we have started with gravitational force. What are the properties of gravitational force? What are the properties of gravitational force? KSSV.
So it is always, it acts from the center of the earth.
Correct. Center of the body. It
Yes,
always
sir,
acts
center
at
of
the
the
center of the
body.
body.
Body, and
Direction
it's always vertical.
vertically downwards. It is
Yes,
always
sir.
vertically downwards.
Downwards.
Next its value equal to.
Mg, sir. Fg equals mg.
Correct. Very good. Next, what are the properties of normal reaction force?
So it comes into, like, we'll consider it only when the two bodies are in contact,
Correct.
and it is a push force.
Correct.
So that's
And
it.
its direction is perpendicular to
Okay,
the
perpendicularly. Yes, sir.
perpendicular to the contact surface. Okay.
Yes, sir.
So that is what we studied yesterday. Okay. So now let us see today some problems on that one. Okay. Normal reaction and gravitational force. Okay. Now suppose let us say, for example, let us say, okay, there are three lifts. Suppose let us say we take um, suppose let us say there are three lifts: lift 1, lift 2, and lift 3. There are three lifts. Okay. Now this lift is at rest. Okay. This lift is moving upward with an acceleration of 2 meter per second square, and this lift is going downward with an acceleration of 2 meter per second square. Okay. And now suppose let us say there is a man standing on the lift. There is a man standing on the lift. Okay, in all the three cases. Okay. And the mass of the man is given as 50 kg. Okay. Then find the normal reaction in each case. Find normal reaction in each case. Okay. So that is the question. Okay. Find the normal reaction in each case. So now let us see how to do it. Okay. We know okay. Now let us see, draw the free body diagram of man. Free body diagram of man. Let us represent him like a block. Okay. Let us represent him like a block. Okay. Now tell me, how many forces are acting on man? How many forces are acting on man? This is man right now. Let us represent him as like a block. How many forces are acting on man now? Tell me.
Sir, two.
Two. What are they?
So one is the gravitational force, which is downwards,
Correct.
vertically downwards, and
Correct.
the other one is the normal reaction, which is acting perpendicularly to the contact surface. Yeah, that's right. Yes, sir.
Correct. Okay. So here the man is standing on the floor. So therefore there is some contact. Correct or not? So whenever there is contact, there will be normal reaction. Man will push the floor of the lift downwards, and the lift will push the man upwards. Okay. So when we say free body diagram means all forces acting on body, all forces acting on man, acting on man. Okay. This force will not draw. This force is force on lift. Force on lift. This is not force acting on man. Okay. So therefore we wrote, and now is this lift at now right now the lift is at rest means man is also at rest. No? Correct or not? The man is also at rest. Rest means acceleration is what? 0. Now if you apply Newton's second law, F net equal to m times of A. Okay. What is F net? There are two forces. Either you can write n minus mg, or we can write mg minus n. Doesn't matter. Is equal to m times of A. Is equal to m, because it is at rest, na? And rest means anyway it is 0. Na? This is also 0. This is also 0. In both cases you will get the same answer. So that means n minus mg is equal to 0, or n is equal to what? Mg. Understand? N equal to mg. Okay. Now let us see second case. Let us see the second case. Okay. In second case, what is the difference between first case and second case? What is the difference between first case and second case? Means in terms of lift. Lift is at what? In the first case, lift is at what?
So the first one, the lift is at rest, and second rest, sir.
Correct. In the first case, lift is at rest. In the second case, lift is moving with an acceleration of 2 meters per second square downwards. Okay. Now here also, if you draw the free body diagram of man, tell me. Let us say this is the man. This is the man. First force is what? Mg. Next, normal reaction is upwards. Now, is this man moving? When the lift is moving, man who is standing on the lift, he is also moving, no? Correct or not? He is also moving. So that means he is moving which side? Upwards. Okay. Now what is the equation according to Newton's second law? What is the equation according to Newton's second law? F net equal to m times of A. Now tell me how to write this equation. How to write this equation? Tell me F net. Should I write n minus mg? Should I write n minus mg equal to ma, or mg minus n is equal to ma? Which equation is correct? First one or second one? Bhavya Yashasvi? Bhavya Yashasvi? I think she has some microphone problem. K Yashasvi, tell me.
Sir, I think the first one, n minus mg is ma, because
Correct.
the acceleration is the final acceleration, like acceleration is direction towards upwards.
Correct. So when the acceleration is upward means this force must be greater, na? Then only it will move upwards. Correct or not? Okay. So therefore, first we should write the higher force. That is n minus mg equal to m. This one we should not write. This one we should not write. Are you understanding? Okay. we should write like this only. N minus mg is equal to ma. Okay, this we should not write like this. So therefore, we'll get the equation as what? N minus mg equal to ma, or n is equal to mg plus ma. Are you understanding? N equal. Here we got only mg. Okay. And what is the mass of the man? What is the mass of the man? 50 kg. So 50 into 10. That is equal to how much? 500 newtons. Okay. Now in this case, it is how much? 50 into 10 plus 5 into 50 into what is the acceleration? 2. So that means how much here? 50 into 10, 500 plus 50 into 200. So that means how much here? 600 newtons. Okay. Now let us see third case. In the third case, lift is going which side? In the third case?
So downwards.
Downwards. So that means when you draw the free body diagram of man here, I am drawing the free body diagram of man. Okay. So what are the forces? First force?
So gravitational force, mg.
Correct.
Then the
Now,
normal reaction.
next, is this man moving upward or downward?
Downwards, sir.
Okay, down. So now what is the Newton's second law? F net equal to what? M times
Ma.
of. Now tell me.
So mg minus n equals a.
Ma. Okay. So this
Yes,
implies
sir.
n is equal to what? Mg minus
okay, mg minus
ma. So that means m is 50, g is 10 minus 50 into 2. So that means how much? 500 minus 100. That is equal to how much? 400 newtons. Okay. So have you understood how to find out? In the first case, how much is the n? 500. Second case?
600, sir.
Third case?
400, sir.
So that means if you observe carefully, the norm generally in your 10th class, okay, you will be told that normal reaction is equal to mg, like this. Correct? Suppose let's say if a man is, if a block is there on the ground, if a block is there on a ground, okay, of mass m, then we'll say n equal to mg. Okay, that is true only if the body is at rest. But when the body is moving either upwards or downwards, then the normal reaction is not equal to mg. It is either mg plus ma or mg minus ma. Are you understanding? Here you can see this n equal to mg. It is true only when the body is at rest. Okay. So therefore, we'll write down one important that okay, very important point. Normal reaction is a self-adjusting force. Is a self-adjusting force. Okay, that means it is not a constant. See here you got 500, here you got 600, here you got 400. Depending on the situation, it changes. Whereas gravitational force, which is equal to mg, is a constant force. Is a constant force. It doesn't change. Is a constant force. It doesn't change. If you want, you can see here. Here in the free body diagram, you see here how much is the gravitational force? First case. How much?
mg, sir.
Second case.
mg, sir.
Third case.
Third case also mg.
But normal reaction in this case, how much we got? First case.
mg, sir.
Second case.
mg plus ma. And third mg
case,
is minus ma.
mg minus ma. So that means this point is very important. What is that point? Normal reaction is a variable force. Okay, it is a variable force, whereas gravitational force is a
constant force, sir.
Constant force. Irrespective of whatever situation you are in, it is a constant force. Whereas normal reaction is a self-adjusting force. Okay, this is very important. Okay, so next problem. Okay, you have gone to parks. Have you gone to park? Children park?
Yes, sir.
Okay. In that children park, there will be slides. You must have seen, correct? Children like slides like this. Correct or not? There will be parks, okay, and then here there will be steps like this, okay. They'll go on steps, and then when they come here, okay, they'll just sit here. They'll just sit here, okay, sit like this. Then what will happen? They'll slide, correct or not? Okay, they'll automatically slide, okay, like this. Okay. So now our question is related to that one. Suppose let us say this is the inclined plane. Okay. Now it's a slide, and then there is a person who is sitting here. Okay, and this angle is 30 degrees. Okay, this child mass is m. Okay. Now when he just sits, he will slide. Correct or not? He will slide like this. Correct or not? Okay. So what is the acceleration? Find acceleration. Find acceleration of this child. Okay. So here also what we have to do is we have to draw the FBD. You have to draw the FBD. Okay. You have to draw the FBD of child. FBD of child. Okay. So now to draw the FBD of child, what we have to do is consider this child like a block. Okay. Consider this child like a block. Okay. This child like a block. Now tell me, what are the forces acting on this child? Tell me. What are the forces acting on this child? Keshasvi.
So again, those same forces: gravitational force, normal reaction.
Correct. Gravitational force will always act from the center towards what? Vertically?
Downwards, sir.
Then normal reaction?
Is perpendicularly towards upside because it is to the perpendicular contact surface.
Correct. Now, in the previous case, we have seen that all the forces are in vertical direction or some horizontal direction. Okay, like this. But here, if you observe carefully, this normal reaction is like this, mg is like this. Okay. So whenever like this inclined plane situation comes, what we have to do is a very important point that resolve all forces. Okay, either parallel or perpendicular to the direction of acceleration. Perpendicular to the direction of acceleration. Either parallel or perpendicular to the direction of acceleration. Okay, you should always remember this point that whenever forces are in different directions, resolve all forces either parallel or perpendicular to the direction of acceleration. Okay. Now let us see here how many forces we have, Keshasvi?
Sir, two forces.
Mg and normal reaction. Now, is this normal reaction parallel or perpendicular to acceleration? Acceleration is this one. Acceleration is the direction in which the body will move. Now tell me, is this parallel or perpendicular?
Sir, perpendicular.
So that means it is perpendicular only. Now already it is perpendicular to the direction of acceleration. So we don't have to resolve that one. What about mg? Is it parallel or perpendicular?
Sir, not parallel, not perpendicular. It is acting
Correct.
in an angle.
Neither parallel nor perpendicular. Okay. So therefore, what we have to do? We have to resolve in two directions. Okay. Either parallel to inclined plane or perpendicular to the inclined plane. So therefore, let us resolve like this, and like this. Okay. Now this component is parallel to the inclined plane. This component is perpendicular to the inclined plane. Correct? Now what is the angle is if you extend this gravitational force downwards, this will meet ground at an angle of 90. This is 90, 30, that means this is how much? 60, correct or not? This angle is 60, okay? 90, 30 and then 60. So that means this component which is along the inclined plane will be how much now, tell me? Will be how much? Mg cos theta or not, correct or not? It is mg cos theta or not, this component, this is mg cos theta, where theta is 60, okay? And this one is how much? Mg sin 60, because angle is with this one, no? This angle is 60, correct or not, okay? So therefore now if you want you can remove this one. If you want you can remove this mg force. If you want you can remove this mg force. Now how many forces are there total? Now you can see clearly. Now, how many forces are there total? Now tell me, Yashasvi. Now, after resolving, how many forces we have? Tell me.
So 3 forces.
Correct. What are they?
So normal reaction, which is acting perpendicularly towards upwards, and we resolve this gravitational force into 2 components, mg cos 60 and mg sin 60.
Correct. So mg cos 60 and mg sin. Now mg cos 60 is parallel to acceleration, correct or not?
Yes, sir. And mg sin 60 is perpendicular.
So that means now everything is either parallel or perpendicular. So now you can what you called now you can write the equation. Okay. Now you consider in the direction of acceleration as x-axis and perpendicular direction as what? Y-axis. Okay. Now tell me in x direction. If you write F net equal to ma, tell me what is the F net? Only force acting is what in this x direction?
Mg cos 60, sir.
Correct. So mg cos 60 is equal to m times of a. So mm gets cancelled. So a is equal to g cos 60. Cos 60 is what? Half. So that means g by 2. So that means 5 meter per second square. Acceleration is 5 meter per second square. So that, and now in this direction, what will happen? Tell me, in this y direction, what will happen? Is the child moving either upwards or downwards? No, no. He will move only along the inclined plane, correct or not?
Yes, sir. So the y direction should become 0. That
Correct.
means like n equals mg sin 60?
Correct. F net is 0 means n is equal to what? Mg sin 60. Are you understanding? So this normal reaction will adjust. Okay. Suppose if mass is, suppose if a fat person also sits, no problem, or thin person also sits, no problem, because n is adjustable force, na? Okay. It will change the value. Okay. Depending on m, suppose if child is 5 kg, then n will be having some value. If child is 50 kg, then also n will have some other value. Okay. So it is adjustable. Okay. So that's why whenever we sit on the slide, we slide, correct or not? Why? Because of this force. Which force? Mg cos theta. Because of this force. There is no other force, no? So because of this force, we go down. The child goes down because of this force. Have understood why the child goes down? Because of what? Mg cos theta. Have understood? Okay.
Yes, sir.
Okay.
Sir, just a small thing. Bhavya is waiting in the lobby, it seems.
Oh. Jayshree is there. Jayshree, are you able to understand? Jayshree? Jayshree? I think she is not. Okay, next one. Next problem. Okay. Now let us say there is ground. Okay. And let us say there are 2 blocks. Let us say there are 2 blocks. One block is this one. Another block is this one. Okay. This block, let us say this is block A, this is block B. This is block A is 0.2 kg and block B is 3 kg. Okay. Now question is find the normal reaction between all surfaces. Between all surfaces. Find the normal reaction between all surfaces. Okay, that is a question. Okay, so now how to solve this one. Okay, now let us see how to solve this one. Okay, first one, draw the free body diagram of block A. Draw the free body diagram of block A. Okay, so that means this is block A. Okay, now tell me what are the forces acting on block A? Keshasvi.
So
What are the
again,
forces?
gravitational force and the normal reaction.
Correct. Gravitational force is equal to how much? Mg.
Mg and
Now here normal reaction means block A will push because there is a contact. Here there is contact, let's say 1, and another contact is contact 2. Now at contact 1, A will push B downwards and B will push A upwards. So therefore this force we should draw. So that means this is normal. Now is the body at rest or
rest, sir. 0.
so F net equal to 0. What is F net? How can you write N minus mg? So N is equal to mg. M is how much? 0.2 10. So that is equal to 2 newtons. N is okay. Next, after this, let us see free body diagram of block B. Free body diagram of block B. Okay. Tell me first force. Bhavya Yashasvi, tell me.
So gravitational force, sir.
Correct, very good. Mg. Next. This block
Normal.
block B is having how many contacts? Block B is having how many contacts?
2 contacts, sir.
Correct. First, let us see contact 2 with ground. In which direction normal reaction will be?
Upwards.
Correct. Upwards. That is, let us say N2. Okay. Next, here contact is there, na? Between A and B. At that point, what will be the direction of normal reaction? Downward or upward? Now, this free body diagram of B means what? Forces acting on B. Forces acting on B. Forces acting on B. That means now A is applying force on B, na? This force. Correct or not? This is the force on B. Na? So that means it will be in which side? Downwards. That is equal to N, which we took it as here. See here. This is action upwards. Reaction is what? Downwards like this. Are you able to understand? Okay. So now here is this body moving? Is this body
No,
moving?
sir.
So that means acceleration is what? 0.
0,
so
sir.
F net equal to 0. Now tell me what is the equation? Downward, how many forces are there? Downward, how many forces are there? N and mg, correct or not? N plus mg minus n2 equal to 0. Okay. Now N we already know 2 newtons plus mg is what? What is the mass of this B block? 3 kg. So 3 into 10 minus n2 equal to 0. So n2 equal to how much? 32 newtons. Did you understand?
Yes, sir.
Yes, sir.
Okay. So like this we should do problems. Okay. So here suppose let us say you take, let us say block A is there, block A. Okay. Here we told that it is at rest. Suppose same block, suppose let us say same block is moving upwards. Suppose same block is moving up. How to write the equation? Suppose assume that block A is moving upwards. How to write the equation? If these are the forces acting, mg downwards and normal reaction upwards. How to write the equation? Tell me. Keshasri?
Sir, N minus mg is A.
N minus mg equal to ma. Okay.
Yes, sir. I'm forgetting M every time.
Suppose if it is going downwards, suppose let us say the same block is going downwards.
So then mg minus n equals ma.
Correct. Mg minus n is equal to ma. So whichever side is going, that side you write the first force. Okay. And then opposite forces you write with minus sign. Okay. So I hope you are clear with this. Okay. And next problem. Now, right now, in the previous problem, we took two blocks upward, one upon each other. Okay. Suppose let us say there are two blocks which are side by to each other. Like this. Okay. One is 5 kg. This is 5 kg. Let's say block A, and this is block B, which is 2 kg. And now I am applying a force of F equal to 100 newtons. I am applying a force of F equal to 100 newtons. Okay. Question is draw FBD of both blocks. Draw FBD of both blocks and find normal reaction and acceleration. Okay, so here also what we have to do is just we have to go by the free body diagram only. Okay, there is no other alternative. Okay, so we have to draw the free body diagram of A and free body diagram of B. Okay, now let us see. Free body diagram of A. Now tell me what are the forces acting on A? Tell me. See here, first force is we are applying force 100. Okay. First force is gravitation force. Always we should write. Okay. Gravitation force will always be acting vertically downwards from the center of the body. That is equal to mass of block A into G, mg. Next force is external force of 100 newtons. They gave. Next, tell me how many contacts are there for block A? How many contacts are there?
So 2 contacts.
Correct. One contact is this one, another contact is this one. Okay. So let us see ground contact. So here pushing force, na? So A will push the ground and ground will push the A, block A. So now when we say free body diagram means forces on A. Now on A means ground is applying force on A, which side? Upward. So let us say that is N1. Okay, next here contact is there between block A and B. A will push the block B right side and B will push block A left side. So that means left side force. This is called as N2. You understood this one?
Yes, sir.
Now same way, what is the free body diagram of block B? What is the free body diagram of block B? How to draw the free body diagram of block B? Now, how many forces are there? Sorry, tell me. First force is what? First force is mass of
mg,
block
sir.
B into mg. Now tell me how many contacts are there here also?
So 2 contacts.
2 contacts, sir.
Correct. Tell me now for the ground, what is the normal reaction?
So it is perpendicularly upward.
Correct. That is, let us say N3. Now what about N2?
N2 is like it is towards right side.
Correct. Because this one are action and reaction, correct or not? This N2 and
Yes,
this
sir.
N2. Okay. So that is how we should draw the free body diagram. And now, just by common sense, you think when you apply force on block A, both the blocks will move or not?
Yes, sir.
Which side?
Right side.
So that
At the
means
right side, sir.
this block is moving right side with acceleration A. This block is also moving right side with acceleration A. Okay. Now tell me in x direction and in y direction. Tell me in x direction F net equal to ma. Tell me what is the equation in x direction. Next direction. How many forces are there?
Sir, 100 minus N2 is MA.
Correct. 100 minus m2 equal to ma. Why we wrote first 100?
Sir, because the acceleration is towards right side.
Correct. Okay. If acceleration is left side, then we would have written n2 minus 100 equal to m.
MA.
Okay.
Yes, sir.
Correct. So that is equal to. Okay, keep it like this. Okay. In y direction, F net equal to ma. Will the body move in y direction just by common sense?
No, sir.
That means acceleration
sir.
is what? Acceleration
Zero.
is
Zero.
now tell me if acceleration is 0, that means these
Then
two forces.
N1 is so equal. Yes, sir.
Correct.
N1 is MAG.
What is the mass of block A? 5 kg. Correct?
Yes, sir.
So 5 into 10. That is how much? 50 newtons. Okay. Now come to here, block B. In x direction, tell me what is the force F net equal to ma. Tell me. In x direction. X direction, how many forces are there?
So only one force.
So that means N2 equal
N2 equals MA.
M is mass of B. Correct? Mass of B
Yes,
is what?
sir.
2. So
2
2A.
kgs.
Equation number 2. Next, in y direction.
N3 equals MBG, which
Directly
is 20 newtons.
correct, which is equal to 20 newtons. So that means N3 we got, N1 we got. Now we have to get only N2. Okay. So for that we have two equations, 1 and 2. So what we'll do, substitute N2 here. Then you will get how much? 100. This is first 100 minus what is N2?
2A, sir.
2A is equal to how much here? Ma. This is
MA.
mass of A. That is nothing but 5. Mass of A is 5, no? 5.
Yes, sir.
So that means 100 is equal to 5A plus 2A, 7A. So A is equal to what? 100 by 7 meter per second square. Acceleration also we got. Now what about N2? N2 we can get easily because 2A. No?
2A, sir. Yes, sir.
So that means
2
A is
into 100 by 7.
200 by 7 newtons. Now all we got or not? Correct or not?
Yes,
N1
sir.
we got 50 newtons. N3 also we got. N2 also we got. Acceleration also we got. Correct? Easy or difficult? Easy or difficult?
Easy only, sir.
Easy.
But should use your brain sometimes.
Baba Yashasvi?
Slight difficult, sir.
Slightly difficult, huh?
Yes, sir.
Where are you finding difficulty?
So on the directions.
Directions, which direction? Normal reactions, huh?
Yes, sir.
Normal reaction directions are easy only, na? See here, suppose
Little I'm getting confused, sir.
okay, I'll explain here. See here. Suppose let us say there are two blocks. Blocks are in contact, correct? Okay. Now, what I'll do is I'll separate these blocks for a moment. I'll separate these blocks. Now see here. Okay. Now, actually, they are in contact like this. Actually, they are in contact like this. Okay. They are in contact. Otherwise, I'll do like this. They are in contact like this. Okay. This is the bigger block, and this is the smaller block. I'm separating. Okay. Are you understanding? Just for understanding, I'm separating here. Okay. See here, this is block A, this is block B. Okay. Now here there is a contact. Here there is a contact. Okay. Contact means there is a normal reaction. Normal reaction means what? Pushing each other. Pushing each other. They don't like it. They don't like it. So A doesn't like B. So what it will do? Bhavya.
So it will push, sir.
Which side? When
At
it
the
doesn't
right
like,
side.
and B also doesn't like A. That means what it will do?
So it pushes at the left side.
Correct. So now this is block A and this is block B. Now you tell me on B block, which side is the force?
Left hand side, sir.
B block.
So, sorry, right hand side, sir.
Correct. And on A block?
A is left hand side, sir.
That's all. You just remember that they are enemies. Understood?
Okay, sir.
Okay. Just like what do you call you and your sister. You have sister, na? Elder sister.
Yes, sir.
So when you fight for something, you push each other, na? Correct or not? Okay. You push your sister, and your sister will push you. Correct or not? Okay. Pushing means you will push away from you, na? It's not that you'll what you call pull your sister towards you. Correct or not? When you don't like, what you will do? You'll push away, na?
Yes, sir.
Like that. Same way, now here also there is a contact between block A and ground. There is ground na here. Okay. So block A doesn't like ground. What it will do?
It pushes downwards, sir.
And in turn, ground also doesn't like block A.
It pushes upwards.
That's all.
Okay, sir.
So free body diagram of block is over for you. Same way, ground is there here. Correct or not? B. Between B and ground there is contact. So B doesn't like ground. So what it will do?
Again pushes to the downwards, sir.
In turn, ground what it will do?
It pushes to the upwards.
That's all. This is the free body diagram of block B. And apart from
Okay,
this,
sir.
there is one force which is called as what?
Gravitational force, sir.
That's all. Free body diagram is over or not? Just now.
Yes, sir.
And of course, for block A, there is one more force. F is equal to 100. Easy or difficult now?
Easy, sir.
Okay. You just remember that fighting. You and your sister are fighting. This normal reaction is just exactly, it resembles fighting. You don't like her, so you push away. She doesn't like you, she pushes you away. Same way here, wherever there is contact, there will be always what you call repulsive force. Are you understanding? Okay, anyway. So what I'll do is I'll give some homework. Okay. I already sent in the WhatsApp. Okay.
Good morning, sir.
Good morning, Anushka. What happened? You thought it was 9 o'clock.
Oh, sorry, sir. I forgot.
You forgot. Acha, acha. Okay, okay. So anyway, today
Thought
just,
it is 11 and 12.
what happened?
I thought it is as normal 11 and 12.
Acha, that's what. Actually, we called you. KSSV has called you. I think you're
I
not.
saw that, sir. It is in silent mode.
Acha, acha, acha. Okay, okay. Anyway, recording is there. Okay, so no problem. Okay. So today I'm giving homework on this today's discussion. That is, today we just revised gravitation force, normal reaction, and then we solved some problems. So based on the discussion, I'm giving you this homework. This homework, this file, word file will be kept in your WhatsApp. It's simple only. Yesterday's class only, Anushka, nothing to worry. Based on yesterday's class only, today I solved problems, different models of problems, lift problems and two block problems and all. So today you can solve these problems. Question number 1, question number 2, and question number 3. Up to 3 problems. Okay, these are very easy problems. Okay, only thing is you just have to know how to draw the forces. First problem is a block of mass m, force is right side. Second problem is force is applied at an angle theta upwards. Third one, force is applied at an angle theta downwards. Resolve the forces, that's all. In the direction of acceleration and perpendicular to the direction of acceleration. Today, as I told today, okay. Second one, along the inclined plane. Okay, there is a today also we solved one problem, that is a sliding problem. Okay, so when you place a block of mass m, what is the acceleration, what is the normal reaction? Just resolve the forces in direction of acceleration and perpendicular to the direction of acceleration. Same way, second case, force is applied upwards. Third case, force is applied downwards. And D case is force is applied parallel to the ground. And third case is there are two forces. Two forces M1 and M2, which is up. There is a force F1 on towards right side, and two forces M1 and M2 force is applied towards left side, and M1 and M2 forces at an angle theta. Okay, this problem we have solved today, correct or not? And here three blocks also same model. 3 blocks also same model. M1, M2, M3, M1, M2, M3, M1, M2, M3. Forces F and FF. Okay, will you able to solve? Will you able to solve?
Yes, sir.
Yes, sir.
Easy one, I told you the technique for normal reaction. Bhavya Yashasvi, correct or not? Okay. You also have sister, na? K Yashasvi? No, brother, na? K Yashasvi? Hello.
Hello. Hello.
K Yashasvi?
Yes, sir. Brother, sir. I have a brother. Elder
Elder or younger?
one. Elder one.
Elder. So when you fight also, you think in that sense, okay? That is the best example. Whenever you have a doubt of normal reaction directions, you think that you and brother doesn't like, correct or not? So you will push your brother and your brother will push you. So that means repulsive. Okay, same way Anushka also, okay? So remember that example, okay? Then you will never make a mistake, okay, in the direction of normal reactions. And then afterwards, once you draw the normal reaction gravitational force, it is just only what you call applying the equation. And I told you how to write the equation also, correct or not? And then afterwards, if the forces are applied at some angle, just you have to resolve it into two directions. One direction is along the direction of acceleration, another one is perpendicular to the direction of, just like here. So I'll give you an example. Suppose here this block is there. Second case. Okay. In the second case, suppose let us say there is a block like this. Okay. Force is applied like this. Now at an angle theta. Now block will move only in this direction, correct or not? Ground. Okay. So now you resolve this force into two parts. One in the direction of acceleration F cos theta, another one in perpendicular to the direction of acceleration F sin theta. Always first you see acceleration in that direction and perpendicular to the direction you should resolve. That's all. Okay. So that's all. And then what are the other forces? Mg, and another force is N. That's all. Okay. So in vertical direction you have two forces: normal reaction and F sin theta and Mg. Okay. Will not move. Means upward force must be equal to downward force, like this. And in this direction it is only one force is there. Which force? F cos theta. So F net equal to what? M times of A. So F cos theta is equal to ME. So A is equal to what? F cos theta by M. And here they'll ask normal reaction. Normal reaction is equal to Mg minus F sin theta. That's all. See here, N equal to Mg minus F sin theta. And acceleration equal to F cos theta by M. Are you understanding? Same thing here also.
Yes, sir.
C part also the same thing. Okay. Will you able to do homework?
Yes, sir.
Yes, sir.
Yes, sir.
Okay then. Thank you all very much. So tomorrow there is no class.
Sir,
Again we'll meet.
sir, just a small doubt. Like for the exam, we are having only the written motion in 2 dimensions.
Correct.
Sir, so the most of the questions will be from that topic only.
Correct. That topic only.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Thank you all very much. Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay.